This is image generation in Elixir, aka we've got AI slop now too. Okay. So this base image here, I generated it with my own thing. I put so I think my prompt was like Mario riding Yoshi, but Yoshi is Python, and Mario has an Elixir drop on his head, but it didn't get the drop, so I had to do that myself. So this is my edit, was to drop the Elixir drop on top. But this is the idea: is that Elixir is riding Python, and Python is doing a lot of the heavy lifting. So we have all of these great machine learning kind of libraries in Python, and one of the reasons why Jose decided to go in the direction of machine learning and is to sort of start to take over that space. But Python is like very far ahead, and so we need to be able to start using those libraries. So recently they wrote a project which seems kind of crazy on the face of it, called Python X, that is basically running Python as a NIF. Okay, so for anybody that's familiar with Python, you've probably heard of CPython, which is basically running Python from C. So they're running CPython as a NIF, and then running Python within CPython as a NIF, if that makes sense. Do we follow? Okay. Okay. So you're running Python as a NIF, which from a seasoned Elixir Erlang perspective, you're probably having like alarm bells go off, where you're like, I want to distance myself from Python. I don't want to like bring it into like my Beam thing. But there are options. I mean, you could run it as a separate node. You have options, right? But this is basically a way of being able to do this sort of stuff that you're doing from Python without taking a performance hit.
Yeah. So how does it interact with GIL?
With the GIL?
So, like, yeah, when you run into a GIL, because like
yeah.
Elixir like naturally like multi-threaded,
yeah.
like multi-process, and Python like say like no, just one. So like if you have like in multiple processes like running Python, like does it slow down Elixir? Do you know like?
Yes. So if you go to the Python X library, like one of the first paragraphs is like basically a caveat about the GIL, that you probably shouldn't use it, but they are working on trying to get a GIL-free implementation, because they're actually in Python itself, they're working on a GIL-free implementation. So that will be in the future, they'll have some sort of a GIL-free version, but right now it's basically like, if the code you're using, you know that it's using the GIL, then you probably shouldn't be doing it this way, right? So your options for running Python from Elixir is basically you can run it inside using Python X, or you can run it outside using Python plus a port. So for those that are unfamiliar, port is basically like a captive terminal in a sense, where like in the same sort of way that you could run Python from a terminal and then, I don't know, poll it or something like that. So a port is basically just saying we're going to latch onto that terminal permanently, and we're going to suck everything that it delivers, and we're going to be able to put stuff directly into it. So it's a way of sort of making a sidecar for Elixir, and that's been the traditional way to interact with Python forever, or for as long as we've been doing this. But this Python X thing is a new thing. Okay, so we'll come back to the Python X thing in a second, but we'll start off with just generating an image, okay? So I apologize for the presentation. This started out as a live book, and then I dropped it into my blog because the live book wouldn't preserve the images, and live book is actually a little bit easier to read, but I had to run this on a different computer because this one doesn't have the necessary hardware in order to be able to actually deliver the images. So in order to be able to preserve the images, I just dumped it into my blog, which is sort of the output of the live book dumped into my blog, which is using Markdown. So if you were to copy paste this code into a live book, it should work because it is just generated in a live book. So later on, if you wanted to do this, you just go to genericjam.com/blog/image generation explained. So a little plug for my blog. Okay, and I'm sure you all knew this, but images are just numbers. So this, if anybody can see this tiny little dot, this dot here, is these four numbers, or these four cells, okay? So RGB, and then all of them. So if you could zoom in on that little dot, you'd be able to see those 4 pixels defined, okay? So a slightly larger image. This is also from a previous blog article of mine. This is how you would write a heart by. So if you guys can see that, believe it or not, okay, this won't show up on the video very well, but there's a tiny little heart inside of a white background. Let's see. Enhance. Enhance. Okay, can we see the heart? Okay, so yeah, there you go. His heart was a few sizes too small. So all those numbers there make up the heart, okay? So you can see how this is going to become quickly infeasible for us to define our images like this with all of these numbers. So that's just to understand like what this thing is doing under the hood is we've got many matrices of numbers that all go together to be able to do something. Okay, so most of this stuff was vibe coded between myself and Claude, where picking apart a Flux library and then putting it together. So basically taking the top off of the Flux library and putting the top into Elixir. So the top being basically like a scheduler and some other bits and bobs, but then we're harnessing Python kind of under the hood. So the first step is we have to start this little server that runs the Python thing in the background. And then, by the way, is this text too small? Should I make it bigger? So for those that have seen my talks before, you know I don't normally present a lot of code. So this would be a first that we're actually presenting code. But you don't have to follow super closely. Just understand like there's some stuff going on in the background. And if you decide to use my library after the fact, you don't have to interact with it on this level. This is like what's in the library, okay? So this is not meant to be representative of what it would be like to use the library. Okay, so the first step is we need to create this thing called latents, which is like the raw randomness that would make the first iteration. So we get all this output from my library, and then that generates a tensor. Okay, by the way, one quick question. What's people's familiarity with NX? Who has heard of NX? Approximately half of us. Okay, so NX stands for Numerical Elixir. And the reason why we needed this library is because Elixir isn't normally a very mathematically capable language, or what's the right way to say that? It's not mathematically performant. And so in order to be able to move in this direction of doing machine learning type stuff, they needed a different library in order to be able to do that sort of stuff in efficient way. So anytime that we're dealing with NX, pardon me? NumPy? It's kind of like, yeah, it's like a chopped down version of NumPy. That's probably the easiest way to understand it. And yeah, NX, it targets the GPU, or attempts to if it can. So also with NX, you need to have like backends. So you can define a GPU as a backend of the CPU, or also you can do TorchX, which is PyTorch, as a backend. So you can basically say, if you're on Mac, you're doing EMLX, or if you're on NVIDIA, it would be EXLA, and if you're trying to target PyTorch, it's TorchX. So you can have different backends, which effectively are targeting the GPU or the CPU differently, and then that maps this, the things differently. But you can also target the CPU. Okay, so NX deals with tensors as like its main thing, and the tensor can have whatever type that you want with it as well. So you can have like float 32, float 64, unsigned, and integers and things like that. So each tensor has its own types, which you'll see. This looks like F16, so float 16, and we have all the floats that are associated with that. So this is the initial latent, which we'll see in a minute, okay, as a visual representation. So the VA decode is bringing that into something that we can then see and work with later on. So we're starting to look familiar here. This looks kind of like an image. So now we need to output it, and we get that. So this is anytime that you have like a text to image, this is the first iteration, is something that looks like this. Okay. So if I was to make it smaller, like 100 by 100, we would just get like this chunk. It doesn't like scale down. It just gets this level of randomness. So this is called noise in this reference. So we need to turn the noise into something. So we need to code the rest of this setup. So if anybody has done this sort of stuff with image prompts, you know that you need a prompt. So we're going to say red heart on a white background as the prompt. That's not a particularly good prompt, by the way, because you need like higher detail. But this is just a code demo, so we're not trying to make perfect images here. And then the guidance scale is basically saying sort of like the level of creativity that you're giving over to the algorithm. So if you say 0, then it should try to follow your directions exactly. And then 15 is like allowing for some level of interpretation. I think so. Yes, I think so. Yes, I've used temperature as well, but I can't remember 100% if they're the exact same thing or if they're approximately the same thing.
I think
probably. It sounds about the same thing. Okay, so now we need a scheduler. So I'll get back into the schedulers later on, but a scheduler is also known as a sampler. So depending on which part of the literature you're going to read, it'll either be called a scheduler or a sampler. Also not to be confused with a beam scheduler. Nothing to do with each other, okay? We're just a collision of terms, but the scheduler is basically the thing that sort of like drives the loop of like iteration over top of this random noise that pulls the noise out and pulls it into something that's going to look like it makes sense. So we have this scheduler that's defined, and this scheduler that I'm using here is DDIM. Like I said, we'll get back into the schedulers in a minute, and I wrote a previous blog post about it. If you guys are interested, you can go take a look at it. It gives a summary of all the different schedulers that can happen. And for this library that I wrote, this Margarine library, DDIM is the base one for the SDXL, Stable Diffusion XL, and it's the only one that's implemented so far because it's basically just like proof of concept. Okay, so next one, we need time IDs, which I don't fully understand why, but it has something to do with driving the loop. Once again, this is something that I'm pulling out of an existing kind of algo that I didn't write. So what does one forward pass look like? So we go unet forward, and then that drives us to the next version of our image. And so we want to convert it back to an image, and that looks almost exactly the same. This is disappointing because, believe it or not, if we were to compare those two beside each other, they're 1/20th different than each other, okay? So if you were to compare them side by side, you'd be like, that one looks a tiny bit different. Yeah. Yes. That's future iterations where I'll be using masks and stuff like that.
Oh, like just to see the like single different, like
Oh.
one iteration gives you can like mask one on another.
Well, you'll see in a minute what they look like right beside each other. Okay, so now we need to run that 20 times because we need 20 steps in this particular image generator. So we're just taking that same thing and then we're putting it into a loop and then we're running it 20 times, okay? And then, so this is the first one and then the second one. So if you can compare those two, right? That one versus that one, 1/20th difference, okay? But it looks a little bit more impressive as you start going down, 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 down. You can start to see it start taking form, down, down, down. And eventually we start having something that looks like a heart. It looks like it's on a white background. Okay, we're not too bad. Okay, fine. We got a heart on a white background. And we got some bonus hearts too because AI is creative, don't you know? Yes. And if you generate different sizes, different seeds, you actually get different interpretations. You get like multiple hearts, you get all kinds of different things. This was just this particular version of it. Okay. So that's basically how image generation works. If you went with image to image, so this is text to image, but if you think about it, if you zoom out a bit, then everything is actually image to image. Okay, because we've started with an image at the top, right? And if you do image to image, what that's going to do is it's going to take your base image, and then it's going to go half of this noise, and then it's going to drive in the direction that you told it you want it to go. Okay, so back here I actually have some examples where I was like messing around on my homepage. So this started off with my thing, and then I wanted it to look like Salvador Dali painting, where it was like melting me or something, you know. So I told it Salvador Dali, but then it just made me look like Salvador Dali, right? So this is starting with a picture of me that obviously doesn't look like me anymore. Actually, all of these started off with pictures of me, and I can't remember. I think I told this one Van Gogh, and then it interpreted it that I wanted to look like Van Gogh. That's what it will do if you go image to image, and then you tell it a direction. It'll try to kind of figure out what that direction is, and it'll go with it. Okay, so relatively clear. Also, if you do like in painting or something like that, where you say you want to cut a person out of a picture, you want it to put a different background or something like that, then basically what you're doing is you're taking your thing and then you're dropping it onto noise, and then you're having noise fill in the part that you're trying to cut out, and then you're trying to tell it go in the direction of like we're on the moon or something like that, and then it will try to turn the noise into the thing that you're telling it to turn the noise into. So the commonality being that it is all basically this image to image iteration of like getting rid of the noise.
Why noise is like why is it not stochastic noise, for example? So it's definitely like not just noise.
Please don't ask any questions I don't know the answer to. Sorry, he asked for those. Why does it deliver this type of noise? I don't actually know, but I suspected that the noise that it generates has to do with the schedulers and the type of noise that it's delivering are tied, as far as I understand. Yes.
You have it doing 20 iterations and each is 1/20th.
Yes.
If you put like 100, is it just going to like heart harder every time?
Heart harder?
Like it's making a heart.
Yeah. I've tried that. So the question is, if you went 100 instead of 20, would you get more heart?
Yeah, like it's
yes.
doing the heart direction harder.
From my experimentation with it, basically it's trying to get rid of the noise, and then once it's gotten rid of the noise, then it's like job's done, and why are we still here?
So the background is saying is like maybe
it's reading noise somehow. Yes.
Okay, so it's like gauging how much noise remains.
Yes. And even okay, so in a previous version of this, I had bugs where it was like leaving these weird artifacts like green lines in the image and stuff like that. And I thought, well, maybe if I just keep iterating, it'll figure out that those green lines don't belong. But no, it was like that part is done. But it was a bug in the code that was basically like eliminating, red or something like that. That was leaving these green artifacts. Okay, so moving on from the image generation to the part where we're bridging Python and Elixir. Okay, so the whole reason why this works like this, if you want to do this from a port, like it's fine, but then your whole thing is written in Python essentially. So if you want part of it written in Elixir, you pretty much want to do it like this, where you're having Python X. If you're putting it as like a sidecar, like on a port, then basically your schedulers and everything are going to be in Python. And I wanted to have as much of it in Elixir as possible, and I just wanted to kind of push the bounds and see what we could do, and see if it was in any way practical. And I think it actually is quite practical. The other thing that's kind of cool about it is that because NX and NumPy can share the memory space, then effectively you can have it in Elixir and Python at the same time. And then because NX is targeting the GPU, then you can just grab that, and then you could like make interim images, and you could do other things with that while the image generation keeps on doing its own thing. So you can do lots of interesting things. I think there's a lot of interesting possibilities that you could go with this. Yes, Grigori.
Yeah. So NumPy is a wrapper on C library.
Yes.
So why do you need to go from Elixir to Python to go to C library? Why can't you just like go from Elixir to C and you don't have to think about like yield at all and like?
Okay. So why don't I just go straight to C, the underlying NumPy or something? So in a sense you could, but there's so much of this code that's written in Python that I have to now rewrite that code in Python. So
this code is a wrapper on C.
not well. Everything's a wrapper on C, right? It's like yes. Like, I mean, I've heard the same thing said about the beam. It's like, well, the beam is written in C, so why don't we just write it in C? Because, so yes, but it's like a very thick wrapper. That's the thing, right? So that is addressed at the end of the presentation. But to skip ahead, it's like one of the main problems with trying to keep up with this space in Elixir is that it's moving faster than we can transpose the stuff, right? So before I did this, there's attempts to do the similar thing with Bumblebee. So show of hands, who has heard of Bumblebee? No? Some people have heard about Bumblebee. Okay, so within this space in Elixir, so you have NX, you have Axon, you have some other things as well, and then you have Bumblebee, where Bumblebee is basically just trying to grab a model off of Hugging Face and then like do what I'm doing, but where the programmer doesn't have a lot of insight into what's happening really. It's basically just like go grab it, make it work, load the biggest model that will run the code, and it's sort of like hope for the best. So that's already there, but they can't really adapt them fast enough, right? So right now their stable diffusion is worse than the stable diffusion that I have. It's like, I don't know, 4 years old. Has anybody used stable diffusion with Bumblebee? No? Okay, I have. It's not good. I mean, it's fine. Like, it's interesting as a proof of concept, but there's no way that you would use it and be like, oh, this is like useful for me for anything other than like an abstract art project. So as near as I can tell, they can't move fast enough to be able to actually accommodate them and build effectively the adapters to be able to make it work with Bumblebee.
So if Python in between is like, so you can right away basically move like at the bases like Python developing and disregard like whatever, like also like drip down into C part to make it performant, but like you still like on the forefront.
Yes.
Whatever forefront.
Yes. Okay. Yeah. So it's, essentially, we can be as performant as Python, or maybe a bit more, perhaps. But where Python, whoever wrote the Python library, is doing a lot of the work for us and has done a lot of the heavy lifting for us. And also, I don't have to like reinvent much apart from rewriting some schedulers. So if you went and looked at the code for Margarine, which we can get to that later, it's not that much code. I mean, there's some there, and there's going to be like 6 times as much at some point in time when I flesh it out a little bit better. But it's doable, whereas transposing all of the Python work that has been done, and the other thing is it's a moving target, right? And so I transpose all that Python code, and then 6 months down the road, like this is the version of Flux that I'm using is Flux.1, and that there's already Flux.2, but that one is not fully compatible. It only runs on NVIDIA, things like that. So I didn't adapt Flux.2, but that's on the horizon already. That we're going to need to be able to adapt that one as well. So you just need to have some sort of a thing that can adapt at the sort of pace that these things are going to come at us in order to be able to say, this is a useful thing within the Elixir world. Otherwise, it's just going to get too dated too quickly. That's my main concern. Any further questions? Yes?
So in your course, you in a loop you like called Python,
Mm-hmm.
and we would reuse Python process, or we would
Yeah. Okay, so you can do both ways. If you want to keep your Python warm, so to speak, then you can put it inside of a gen server and then just keep it going so that you have the same instance, so that you're not like firing up the whole Python runtime every time that you want to start it. So either one can work, but if you want to keep it going, so within the library, that's what I'm doing. Is I'm keeping it inside of a gen server so that the state is saved within the state of the gen server, and then each time it goes around, it's calling kind of like the same Python instance.
The next question, I see that all the library has zero major version. Is it an alpha or like?
My version?
No.
Oh, all of them.
Down, you have packages.
Yeah.
I'm so familiar, but all of them looks like alphas.
They are pretty alpha. I mean, Kino has been around for long enough. I think that one's reasonably stable. Python X, I would say it's probably pretty alpha. I don't know that I would put the code that I'm making right now into production in your like main server. Like I said, if you were going to do that sort of thing, I would probably put it as an external node, and so that if it crashes, it doesn't bring down your main application. But that doesn't really hurt your performance, because basically the time it takes to generate the images is far longer than you're losing in communication with the neighboring node, and plus you're going to be writing it to disk and then accessing it by like referencing the disk location. So it wouldn't hurt you to just run it as a node. Yeah, but the rest of this stuff, yeah, there are a lot of zeros. Although I would say the Elixir community doesn't automatically go 1.0, and also it's kind of 1.0 is kind of considered like a high bar, I guess, in a sense, where you're saying the API is not going to change, whatever. Like this image library has been around for probably 5 years at least now, and it's very well built out. I would say it's very stable. The STB image is actually abandoned, I think, but like I don't think I'm actually using this one, by the way. I just used it because it was using a previous iteration. But EMLX is also very cutting edge. That one basically just came out within the last couple of months. But this is how you can. But this is also for Macs. So Mac, the M series, that's also only a couple of years old. So like that's already been a moving target. But Kino's been out for a long time. It's basically been the thing that's the way that you display things in Livebook. So I think maybe coming from Python, it's a little bit different, because Python's been around for a couple of decades, and then you're already like 2.0, 3.0 sort of thing. But in a lot of the libraries in Elixir, people are not really that bothered by a 0 dot whatever. But yeah, my library is definitely very early. So just, that one's like completely full of warnings for sure. But some of these are probably a little bit more stable. All right, so we're back to this image. So what we want to do is we want to do something with this image that is like not already facilitated by Elixir and X. So we're going to do a little Python toy project here. So this is how you set up your Python X. So if anybody that's done Python understands UV, and like this is basically like your requirements file in UV. So anybody, can I get an amen from the audience of like Python aficionados? So yeah, this is something actually that Claude always messes up too, is that it forgets that it needs to do this UV thing, and also it thinks that there's a thing called pythonx.call, which there isn't. There's just pythonx.eval. So yeah, you set up your Python X. This is actually kind of a cool way of like managing your Python instances as well. And for anybody that's coming from Python, that should make a lot of sense. So we want to open that image. We want to turn it into a tensor right away, and then we're going to turn it into binary, and then we want to take that and put it into Python and manipulate it with SciPy, and basically apply a Gaussian filter, and then we're going to return it back to Elixir. So this is all using the same memory space, just so you know. So for anybody, any of the seasoned Beam vets here, like, pass by reference is not really a thing that we do. We pass by, message passing. That's like the name of the game here. But this is how Python X is able to, cut that corner for you. Yeah, so at the end of it, we're gonna lay it out with Kino and some debug messages, and we have a Gaussian filter applied. So that's what you can do. You can go get yourself a Python library that covers something that isn't already done in NX, or you can take whatever your pre-existing Python knowledge and do whatever it was that you were going to do in Python, but in Elixir, and switch back and forth. So I kind of already covered this, which is essentially so you can share the memory and we don't have any performance hit. And why not do more in Elixir, because it would be too much work. Okay, so I don't know how much more patience you guys have for different stuff, but I have these demos. So does anybody have a safe for work image prompt they want to see happen? No.
See a T-Rex riding a skateboard.
T-Rex riding. No, I spelled it wrong.
They gotta make that dark mode.
So this is the stable diffusion generator, and once again, this is not built with the library. This is like previous experiments, and so not all these features are in the library yet. But you can do all kinds of different stuff with stable diffusion. So here's some examples of things that I already generated beforehand. My friend stuck his dog through, and then it turned it into like this weird C3PO burrito kind of thing.
Oh, that's Thanos.
Yeah.
That's straight up Infinity Gauntlet dog.
Yeah. And then for my blog, I wanted to generate all these jam things because my handle is generic jam. So I don't know. I accidentally I seem to have a thing for like spreads, because generic jam and then margarine. I don't know. The next one is like peanut butter or something. I'm not sure exactly.
Nutella's already taken.
Yeah, maybe we'll do Nutella next. Uh-oh, something went wrong. Hang in there while we get back on track. Did I lose my internet? No, that's going to be a problem.
Server room is now loud. I mean, you did say in a volcano.
Yes, in a volcano. Unfortunately, I don't have a way to generate it on this machine because it's on my machine at home. So hopefully this connection recovers. So anyway, what else to say? That's about it. Does anybody have any other questions about this?
Yeah, what's your hosting environment like?
On a Mac Mini at home, and then I use Cloudflare tunnels because apparently it's like insecure to just expose your home IP. I mean, so I'm told. I'm waiting the scientific evidence on that one. Yes, sir.
This is not like directly related to image processing with Python and Elixir, but I think today or yesterday, Oban released a Python library.
Yeah.
Oban and Oban Pro.
Yeah.
In Python, it's fully in drop.
Mm-hmm.
Elixir, so there's like a full-on merging of the two ecosystems happening. It's
Yeah.
cool to see.
I actually I think that the merging thing is a decent way forward. Actually, like for anybody that's familiar with Tidewave is also targeting other other ecosystems. So yeah, I think the idea of being just like a complete purist and saying it's Elixir or nothing is kind of the wrong approach. Like basically choosing the right part for Elixir, and also just being kind of open to other things that maybe somebody else has something to offer us. But like in this machine learning space, I don't know if people have heard of the strangler pattern before. Um, well, something. Somebody unplugged my machine at home or something. I don't know exactly. Yeah. my home router went down or something. I don't know. Anyway, I can't access that anymore. Yeah. Maybe my son reset the internet or something. I don't know. Uh, yeah, I think there's middle ground. Like, uh, how many people have heard of Zig? Yes. So Zig is attempting to do the strangler pattern on C, essentially, right? Where it's fully interop with C, right, while providing a better alternative at the same time. So all it needs to do to be better is, or to be a better choice, is just to be slightly better than C, which really isn't that high of a bar when you think about it. So by being fully interop with C, it can fully replace C. So I think taking that sort of pattern with Elixir and Python, if you're trying to say to your team, like you have to completely abandon Python in order to be able to go forward with Elixir, it's the wrong approach. And being able to just say, well, we can take what you're doing and somehow integrate it. And whether Elixir really should like replace the other one or not, may or may not be the right way to go, depending. Yeah.
Probably complement is a better word.
Yes. Yes. It can be a complement, but it can also, integrate. Let's see if this is recovered. Nope. Okay. So anyway, the dangers of not exposing your home IP address is that you may just have your server die in the middle of your talk or at the end of your talk. Any other questions? I wanted to share the image on Discord that I put up there that nobody even saw. So this I asked Claude.
The library picture,
Yes.
I think Claude thinks of himself quite highly.
Yeah, but I mean that's actually kind of cool, right? Like, there's so many people that would say that AI art is just completely derivative, right? Or it's like, oh, you're just copying somebody's style or whatever, right? But like, this is nobody's style. I don't think anybody draws pictures of libraries that go on forever, and that kind of is a morph between a mirror and a window and whatever else is going on here. So I think it's kind of cool actually that we're able to have the thing introspect, whether or not you think it's thinking. Okay, let's just put that aside for a second. Whether you think it's like aware of its own existence, but I did find it very interesting that when you're asking it to reflect about itself, it includes in the prompt a mirror, right? And the mirror test is something that you say about an animal that's self-aware, right? If an animal can go up to itself and go up to a mirror and recognize itself, then it's like some form of self-awareness. So anyway, I thought that was an interesting nod.
Similar topic is like if you're using some like Claude or ChatGPT long enough, you can ask it to inspect you as a user.
Yes.
So giving you like question styles also like can be interesting to read.
Daniel Miesler, Telos file. It thinks it's the long room in the library at Trinity College.
Yeah.
Oh, that looks like the library at Trinity College.
Libraries are filled with like good books, and Claude is filled with like everyone's Python and JavaScript code.
There's a bit of a difference. He doesn't get to pick what he reads.
Yes, exactly.
What a horrible thing. Sounds like being a developer and having to read the docs. He's got a code review, all code.
Yeah.
In fact, that's all he does with his life is code review. Yeah.
Yes.
Like, that would be the worst.
Yes.
And they're not even structured.
There's a lot of repetitive parts in introspection.
Oh. Sorry. What? One more image to share. Oh no. I can't. Now you have to go look it up on your own.
Yeah.
No. Okay. There's I've been posting a lot of image generated stuff that I generated with Flux. So if you want, you can go look at it on the blog of all the different image generated stuff. This is the stereotypical astronaut riding a horse on Mars. That series, and this is with Stable Diffusion. So this is not even with Flux.
There's
So-
not a single Thark in that picture.
Not a single Thark. What is a Thark?
Green Martian.
Oh, okay.
4 arms. John Carter Mars.
Oh yeah. Correct.
If you're gonna ride a horse on Mars,
Yeah.
you should be using sword.
Yes.
Have hot red chicks all around it.
Yeah. Also, the astronaut gets a spacesuit, but the horse is just like, you're on your own, buddy. You're bioengineered, I guess, or something. Okay, are we done? Okay. No further questions? All right, we can wrap it up.